In this video, I'm going to take a look at the painter problem. You can find this either as the last problem in your notes packet or your homework packet. It's the same in both. So this is one more example of linear programming that is laid out for you in a way that should help you organize your thought process. The hard thing about linear programming is it gets overwhelming because there's so much going on. But when we give you the constraints and the table at the bottom, that should help guide your thinking. So I read the problem, and it says a painter has 32 units of yellow dye and 54 units of green dye. A gallon of chartreuse paint requires 4 units of yellow and 1 unit of green. A gallon of lime requires 1 unit of yellow dye and 6 units of green dye. What is the most number of gallons of paint he can make? So ultimately, I'm trying to maximize the number of gallons of paint he makes, but that doesn't come until the table in the end. Before that, I need to make sure that I'm writing those constraints. And again, for me, the reason this one's confusing is because all of the information is kind of mixed up. But we actually tell you what the variables are, and we actually give you the constraints, which means that when I go back and reread the problem, everything that talks about yellow dye, I'm going to underline, okay? So I'm going to actually put a box around this because that's going to be profit, or the maximum. Okay, so I reread it, and then the other constraint is green dye, so I'm going to squiggly under those. So it says a painter has 32 units of yellow dye. So I'm actually just going to underline that. Originally, I would have maybe thought that yellow dye is X, but that's actually not the case. 54 units of green dye, because those are going to be part of these constraints. A gallon of chartreuse. Now we've just introduced something new, and so that's going to be our variable. So X is the number of gallons of chartreuse. It requires 4 units of yellow dye. So I underline and 1 unit of green, which means I'm going to squiggly underline it because those are 2 separate constraints. A gallon of lime, okay, so this is now my other variable, so that's going to be Y, as you can see down here. We won't always give you that part. Requires 1 gallon of yellow, 1 unit of yellow, sorry, and 6 units of green. So now when I go back to write my yellow dye constraint, I take the 3 pieces that are underlined, 32 units of yellow, 54 units of green. Those are the maximum number of amounts. But when I go to write my equation for chartreuse, chartreuse needs 4 yellows. So that's 4 for each chartreuse. But the second part of that I don't use. I actually now go over to lime, and lime needs 1 unit of yellow, so that's plus 1Y. And again, now I go back up here, the most we can use, so less than or equal to 32. So again, this one's a little more challenging because you have to kind of jump around, but that's why I do use this kind of notation to make sure I understand what I'm looking at. Now I go back and do the same thing for green. I need 1 unit of green for chartreuse, so 1 times X, plus I need 6 units of dye for the lime, which is my Y, and I only have 54, so it's less than or equal to 54. Real world, in most real world situations, negative numbers don't exist. So I can't have negative amounts of paint, and there's no additional information given about the paint. So I just say chartreuse has to be X greater than or equal to 0. The lime has to be Y greater than or equal to 0. All right, now when we go to graph these, we have to make sure we can graph them in the grid. They've already given me the grid. We are going to use slope-intercept form, so I subtract the 4x. I get negative 4x plus 32. I think I actually, so I made a grid where I went all the way up to 32, so that's a little bit harder. And then this one, I would start with 6y is less than or equal to negative 1x plus 54, but then I divide all 3 pieces by 6. So I get y is less than or equal to negative 1/6 x plus 9. So when I went to graph this, it's a little complicated. I actually scribbled this out and then I made my own, but I still didn't go all the way up. So 10, 20, 30. So 32 would be like up here. So you are going to have to make your own grid or kind of just follow these points. From there, I go down 4 over 1. And so if I keep going down 4 over 1, down 4 over 1, down 4 over 1, I believe that line ended up hitting over here at 8 0. Okay, so that was this line. Don't forget, I have to test my point. Is 0 less than or equal to 32? Yes, which means that this would shade down. Use this little arrow notation right now for shading down. Don't forget your real world. Technically, we have x equals 0, y equals 0. This is shaded up, and this one will be shaded to the right. Okay, so the real world usually just constrains it to the first quadrant. Sometimes, as you'll see in one of your homework problems, it adds a little more. Okay, now on this one, I start at 9, which would be right about here. That's going to be a key point, 0, 9, because that's the y-intercept, and I go down 1 over 6, which I think ends up over here somewhere. Okay, and again, if I say is 0 less than or equal to 9, yes, which means I shade down for this one as well, which means all these arrows are pointing to this one segment, or one section right here. So that's my critical area. And remember, what I need is the 4 key points that make this area, which we actually call the feasible region. Now, if I had a nice neat grid, I would count, and I need the exact value of this, which is 6, 8. Another option, if you're not quite sure about what that point of intersection is, really you have 2 equations, or 2 inequalities, I should say. You could solve that system algebraically. You could use either substitution or elimination that we learned. Or, because we're doing all this stuff online, you could graph those 2 in the same grid and find the point intersection using your calculator so that you're sure you have the right value. Okay, so now when I go to do this, so it does say check your solution algebraically, so I could plug 6, 8 into both equations. I had to get 4 times 6 plus 8 should be less than or equal to 32, and that gives me 32 is less than or equal to 32. You should get the exact amount if it's actually, because it is when they're equal. So 6 plus 6 times 8 should be less than or equal to 54. Really, it should equal 54, and it does. Okay, but that's not my answer. Remember, what we do with linear programming is we're finding the 4 possible combinations that would maximize the amount of paint. Okay, so those 4 points, the 0, 0, 0, 9, 8, 0, and then the combination of 6 and 8 gallons. Those are the 4 things that would get me there. Having said that, if we're talking about total gallons, usually somewhere in the problem, if it's like a maximum profit, it tells you how much you make for selling each item. This one didn't say anything about that. We just need to know the total number of gallons of paint that we make, or we want to maximize the total number of gallons. So really, we're just taking the total number of chartreuse gallons and adding it to the total number of green. So in this case, my total gallons is just x plus 8. Oftentimes we'll be multiplying in there, but that's if you know how much you make per gallon or per whatever. Okay, so this one's actually slightly easier here. I just add these up. 0 plus 0 is 0, 0 plus 9 is 9, 8 plus 0 is 8, 6 plus 8 is 14. And so here we can see that the way to maximize the number of gallons would be to go with 6 chartreuse gallons, I should say, and 8 lime gallons. So this right here, after all of that work, is my final answer.